This is opening ceremony for TRIDENTCOM 2020. Thanks for your attention. In this year, TRIDENTCOM 2020 had got 37 papers submission and we accepted 14 papers from that. Thanks for your conference committee, such as Professor Wang, Professor Goel, Professor Kwong, Professor Zhang, and Professor Yin. R has become a leading scientific forum for design, implementation and verification of emerging information technologies. Thanks all of you, although COVID-19 impact and we hold online. Please pay attention to next year conference.
Dear ladies and gentlemen, let me welcome you to the EAI TRIDENTCOM 2020, 15th EAI International Conference on Tools for Design, Implementation and Verification of Emerging Information Technologies. I am Aleksandra Sedzejowska, the EAI Conference Manager of TRIDENTCOM 2020. Unfortunately, due to the virus, I am not able to meet all of you in person, so I am using this opportunity to address the organizing committee, the authors, and the participants on behalf of EAI. First of all, I would like to thank all of you for being a part of this conference and for your involvement with EAI. Above all, I would like to express my gratitude to the general chairs, Professor Hongao Gao, Professor Yu Weng, and Professor Li Guang, as well as the program chairs, Professor Yu Yin and Professor Ziyan Zhang, for their hard and excellent work throughout the whole process of the conference preparation. During today's event, you can actively participate in two ways. Firstly, you can join the Q&A on Slack through a link that you can see below this video. Upon accessing the EAI TRIDENTCOM 2020 Slack workspace, you can enter the channel called Discussion. Secondly, you can vote on individual presentations and leave your fellow researchers feedback on their work through EAI Compass. We will shortly show you how you can access these platforms and how to leave and receive feedback for presentations in this conference. To sum up, it is our honor to organize this year's edition of TRIDENTCOM conference. I hope you will have a wonderful time during this event and that you will follow the next edition in 2021. We will keep you posted, and the news about this event will be available on the conference website. Should you be interested in being a part of the technical program committee, please do not hesitate to contact me at my email address below. Similarly, if you are interested in discussing other possible cooperation, organizing a conference or a workshop, please contact me at my email address as well. Now, my colleague Michal will talk more about EAI tools and go into more details about the aforementioned voting. Thank you for your attention and enjoy EAI TRIDENTCOM 2020.
Hi everyone, my name is Michal Dudic. I'm the Community Manager at EAI, European Alliance for Innovation. It's my pleasure to welcome you at this conference and say a few words about who we are and what we can do for you and your research career. In short, EAI is a global community for a greener, healthier and smarter world. As of today, we are home to more than 60,000 members from 167 countries, and we reach out to tens of thousands of subscribers. As an organization, we are non-profit from day one, and what is most important to us is that we remain open to all researchers from all around the world thanks to membership that is completely free. We organize more than 100 events annually, such as this conference, and we do so in publishing partnership with Springer. I said in the beginning that EAI is a community, so let's talk about what that means and what it means for you. To put it briefly, we give our members a platform that builds their research. We do it with 3 main online community services where members come together to help each other write a better paper, get an objective review, and get recognized fairly. The 3 services in question are EAI Compass, Community Review, and EAI Index. Firstly, EAI Compass is an online app where you can meet and connect with new colleagues and get feedback on your paper as well as your presentation. In addition to that, it lets you download all full papers that will be presented at this conference, and you can vote on your favorite presentations as well as see everyone who is here and connect with them. You can do this right now if you go to EAI Compass website, compass.eai.eu. Next, we are improving the classic conference review process with community review. It has already been in use at all our events since 2019, and we were very excited to hear a lot of positive feedback from program committee members regarding the reliability and the speed of the community review. Let's talk briefly about what community review does. Essentially, it is a website that shows abstracts of papers that are right in the middle of the review process, as long as the authors allow it, of course. And all EAI members may then bid to review specific papers. When they submit their bid, they put in their bio and their qualifications, which are sent to the program committee, who can then decide whether or not this bidder is qualified to review the paper they bid on. This relatively easy access to review opportunities means that bidders really need to put their best foot forward if they wish to be selected, which improves the quality of the entire review process. At the end of the day, this benefits you, the author. And last but not least, let me tell you a thing or two about EAI Index. EAI Index is our credit-based evaluation system that we rolled out this year to all of our conferences and journals that allow you to climb the global ranks of EAI community and get recognized for your work. It calculates a number value for most actions you make, such as getting your paper accepted or submitting a review, and these numbers accumulate for 12 months. At the end of this 12-month period, we put together a ladder of all EAI members, and the ones at the top receive a nomination to one of the membership ranks: senior member, distinguished member, or fellow. For each action that is eligible for EAI Index credits, we'll look at the quality of your action as it was evaluated by another member of the community, such as, for example, the review score of your submission. To make sure that the system is fair to newcomers, every 12 months the credit count gets erased, the ones at the top receive their nominations, and every member starts at 0 for the following 12 months. And finally, Smart Submit is a collaboration feature that is coming later this year. It will allow you to submit your research ideas and your work in progress abstracts to get the kind of help and feedback you're looking for. Maybe you are looking for co-authors, maybe you would like to find a mentor or a mentee, or maybe you want to find out how the community feels about your idea. This is what Smart Submit is designed for. Ultimately, it's about helping you write a better paper and increasing your chances of getting accepted. Again, we will be launching this feature later this year, so stay tuned. And so I'm going to leave you with many different ways to get engaged at different levels. There are lots of opportunities in many of our events and publications, which means many ways to connect with people and collaborate. You may learn more about everything I just talked about at our website, eai.eu. These services exist to help you and to make your lives easier, so we encourage you to send us your comments, ideas, and feedback to community@eai.eu. And if you're interested in volunteering and contributing, you can let us know at the same email address. Don't forget that you can use EAI Compass to vote on presentations in real time to determine which ones are the best, as well as to download all full papers that will be presented today. Just make sure that you log in using the same email address as the one you used to register to this conference. Thank you very much for your attention. Please enjoy the conference, and I hope we will see everyone online soon.
Hello, this is Mohammed Rahouti from the Department of Computer and Information Science, Fordham University, New York City. In this presentation, I'm going to present the paper entitled Prototyping an SDN Control Framework for Quotes Guarantees. This paper is co-authored by me, Dr. Kechi Shun from the University of South Florida, and Dr. Yufen Shin from Ramsey, the University of North Carolina. Here is an outline of my presentation. I will first motivate the end-to-end delay, the end-to-end communication delay in SDN networks, followed by our problem statement and challenges, summary of existing literature review. Then I will present the design of our proposed framework and methodology, followed by the evaluation and summary of our findings. And lastly, conclusion and future work. So we all know that the structure of networking topology is complicated, which means we always have multiple paths and directions for sending data flows and networking traffic. And also the network has state fluctuations, which means the network is always dynamic, or in most of the cases dynamic. And the condition and the state of the networking resources keeps changing. So on the other hand, we have SDN or software-defined networking. SDN has become a vital networking paradigm for expediting network management and control. It provides a global view of network resources and decouples the control layer from the data layer. Using a logically centralized controller, SDN permits programmable interfaces to insert and push forwarding rules into the forwarding devices, such as the open flow switches. To insert and push forwarding rules, the SDN controller uses the logically centralized controller perspective for efficient network communication. In order to better leverage the SDN capabilities, the delicate holistic view of flows must be regarded as a contributory factor in networking applications. So when we talk about the end-to-end delay, that always requires efficient measurement between originating source and destination. And since we are deploying software-defined networking in this research, this is a great opportunity to provide more accurate end-to-end delay measurement because of the global view of the globalized view and holistic view of the SDN controller. So talking about the problem we try to solve in this research, dealing with trying to improve quality of service from the end-to-end delay perspective. The end-to-end delay itself involves multiple factors, which means that when trying to improve or address the end-to-end delay issue in SDN environments, that can be achieved by solving multiple sub-problems. The first sub-problem is reducing the impact of metric collection by the SDN controller. So let me simplify that. In order for an SDN controller to collect the topology statistics, such as the per link delay or latency, the SDN controller has to send LLDP packets to every enabled switch, for example, the open flow switch in our scenario. So the SDN controller will send tremendous amount of LLDP packets in order to collect even single per link latency. So that this mechanism causes overhead on the SDN control performance. That's one of the sub-problems that we can also solve to improve the end-to-end delay. Then the second sub-problem we try to deal with is the latency metric estimation. As I just mentioned, every time we try to collect statistics using SDN controller globalized view, that causes an overhead, performance overhead. So can we collect statistics and use these statistics for the next time window estimation of the best path? Then which approach can be the best in order to guarantee an optimal path selection? That's another sub-problem as well. But however, to solve these sub-problems, there are few research challenges. The first one, as I just mentioned earlier, is the network state fluctuations, because the network is usually dynamic, which means if you collect the current statistics and you try to use them for the next time window prediction or estimation, the network state keeps changing. So it's difficult to guarantee the efficiency of the path optimality you are trying to predict for the next time window as the network keeps changing. And also another challenge is that how to fulfill or to what extent you should guarantee service level agreements and quality of service. And another challenge is how to emulate real world or normal networking traffic behavior. The last challenge is usually the incoming data flows or traffic might have different priority levels. So how to classify and service these data flows according to their priority level. In the past, various research studies have been carried out to explore and enhance the quality of service in SDN environments. The majority of previous studies have shed light on the data plane latency performance in terms of packet trip time. The end-to-end delay involves multiple factors, including propagation delay, switching delay, and control plane latency. It is important to note that the data control communication delay, which is basically the delay associated with sending packets from switch to the controller and back. So this delay, or these delays, play a significant role in the end-to-end delay of traffic delivery. Therefore, the centralized control of networking traffic in SDN networks presents an additional factor that cannot be ignored in designing latency control mechanisms. So despite these contributions in the past, there were different contributions on network optimization and traffic engineering management in SDN controller, including end-to-end delay optimization, deploying efficient queuing mechanisms. But however, despite these contributions, various open challenges remain here. For example, there is a further need to leverage the real-time data collection capabilities and queuing mechanisms at both the controller and OpenFlow switch in order to achieve more effective traffic forwarding and dynamic path computation. This is indeed of particular importance to real-time traffic flows with tight delay quality of service bounds. Furthermore, there is also a need to support priority queuing for multiple traffic levels in SDN networks. These data plane traffic priorities also need to be adequately integrated with SDN control plane traffic. So, building upon the framework we presented the last year, we propose an extended prototyping design with enhanced mechanisms to better improve the end-to-end quality of service for traffic delivery with optimized controller's response time. In order to address these end-to-end delay problem described in the paper, our proposed framework architecture and modules are depicted in this figure and consists of 4 main modules. The first module, traffic classifier, which is basically based on queuing scheme, the statistics collector, the time series estimator, and optimal path selection. Each module will be described and detailed in the following slides. So talking about the queuing mechanism, when a new packet arrives in the switch control communication channel causes more latency towards the end-to-end packet delay. Therefore, not matched packet with existing flow rules can affect the end-to-end delay bound more than the matched packets. Therefore, a prioritized service queuing scheme is implemented along with our SDN framework, as depicted in this figure. A priority queue is implemented in the infrastructure layer to separate flows that match existing flow rules from new packet arrivals. Moreover, the classification module classifies incoming data packets into multiple priority levels and then buffers them separately. Keep in mind that feedback control signal is also utilized to design the efficient priority-based transmission of all in-queue data flow. The purpose behind implementing such queuing scheme is to minimize the overall traffic delay, which is partially impacted by the control plane latency given in the following equation, where this delay basically involves the propagation delay, the transmission delay, the queuing delay, and the processing delay at the switch level. Next module in our framework is the latency collection. The per link latency is calculated based upon timestamp injections by our SDN controller via the link layer discovery protocol, basically here the LDP packets. So precisely, the SDN controller transmits these LLDP packets as packet out to all enabled switches in the network. Once the controller receives one of its transmitted LLDP packets, it processes it as a packet in. So building upon this, the controller will examine the LLDP packet timestamp and subtracts it from its current time. And that's how we collect the latency metric for the per link latency metric. Then building upon this module or the collected latency metric, we do latency estimation for the next time window. So in order to minimize the controller overhead caused by statistical collection, we implement an exponentially weighted moving average module for the short run per link latency metric estimation. This module uses per link latencies calculated by the previous module and obtain new estimation of accumulated per link latencies for an initialized window size that must be set by the network operator before launching the framework. So we leave it by default to be 10 seconds. The last module, which is the path selection. So inspired by the A-star algorithm, we implement search heuristic HN in the path selection module for the heuristic search of the optimal path from source to target node. Our path selection module only utilizes the readily acquired per link latency metric estimations between particular communicating pair of nodes. The heuristic HN is regarded as a set of paths between two communicating nodes where the path cost is an estimate rather than actual. Here we come to talk about evaluation. So in our evaluation, we employ two controllers. Our implemented SDN controller along with default floodlight controller software. The default SDN controller software will be used as baseline to compare, to evaluate and examine the efficiency of our end-to-end delay framework. So our evaluation, our topology will be built on GENI testbed, Global Environment for Network Innovation testbed, which is an NSF-funded testbed, a real-world federated and at-scale testbed. So as the at-scale wide area communication is not limited to one geographic region, GENI testbed grants inter-network domains for inter-region communication in order to assess with elaborating real-world experiments over public internet traffic. Therefore, to better evaluate our framework efficiency and evaluate the end-to-end delay within topology connecting multiple sites, we deploy networking resources from multiple sites through the featuring capability of GENI, specifically resources from California, South Carolina, and Kentucky. For the resource setup, we create a real-world topology that consists of multiple sites using deploying Floodlight as an open source SDN control software and the open flow switch, the obvious switch version 1.5. Here we show our performance or evaluation results. The reported experimental runs are conducted for 15 successive trials in an automated manner, and the results are then averaged. So our end-to-end delay evaluation shown on this table and the following figure demonstrated that our developed framework outperforms the default optimization configuration provided by default Floodlight SDN controller software. The table and figure give a summary of our comprehensive experiments. Specifically, this table gives the percentage end-to-end delay improvement in our framework, while the figure depicts visual presentation of the end of the delay in an end-to-end communication between designated nodes in our topology. The figure demonstrates our system outperforms the path selection mechanism adopted by Floodlight controller and implies smaller end-to-end traffic delay. The table also shows that the proposed solution improves the average end-to-end delay by about 10%, some 10% in general. The last experiments, in this experiment, we try to examine the efficiency of our solution in terms of controller plane latency optimization between the same pair of switches in our Gini topology. So based on the end-to-end delay equation shown earlier, we can induce the data control channel latency by subtracting the respective measured delays from the overall end-to-end delay. This figure presents the CDF of control data plane latencies provided by our framework and the default floodlight stream controller. As shown in this figure, our queuing scheme outperforms the default controller with regard to control plane latency optimization. As a conclusion, in this work, we have presented the new STM controller framework that enhances the end-to-end quality of service awareness. The proposed system utilizes various traffic engineering techniques, a queuing mechanism, real-time latency estimation, and heuristic path search to optimize the end-to-end latency in traffic delivery. The system enables prioritization of control plane traffic while minimizing the control plane latency through priority queuing scheme. Our comprehensive experimentation was carried out over Gini testbed to experimentally evaluate the efficiency of the proposed framework. In the future work, we plan to integrate this framework into multiple domain SDN environments and also explore other quality of service metrics such as classification of networking traffic of varying priority levels, and then do the flow routing based on the identified priorities at the data plane level. Thank you very much for your attention.
Good morning. I am Wang from Beijing Institute of Graphic Communication and very honored to share my study on precision improvement of overprinting system based on improved Laplace edge detection algorithm. If you have any question during my presentation, please feel free to ask. Overprinting is an important method of color printing. The basic principle of overprinting is that several different colors of ink are printed to the same paper in sequence. When all the different colors are painted, all the print heads need the same frame of reference. It requires a high location precision, or the final prints will be misplaced. Today, overprinting system is running at a relatively higher speed, which leads to a lower printing precision. To make sure the printing precision meets the requirements, we must limit the printing speed. At the same time, how to evaluate the quality of the prints effectively is also an important task. If we do not find out and solve the problems of printing precision in time, the waste of time and money will not be avoided resulting from defective prints, especially in industrial production. The paper aims at solving the above problems. First, the color picture is divided into 4 color channels: C, M, Y and K. After that, we use improved Laplace edge detection algorithm to locate the center of the cross line. Then the deviations of channel K to channel C, M and Y are calculated. And the deviation is the overprinting error. This paper makes the overprinting error more accurate. As a result, the whole overprinting system can work more accurately. And the printing quality can also be improved. Cross-line detection is important in many industries. To make every color print head work accurately, we often need to print the cross-line of each color and locate the cross-line center by a photo taken by a high-speed CCD camera to realize the calibration of overprinting system. If we can get a clear photo of a cross-line, the method is pretty good. However, the photos usually are of a low signal-to-noise ratio and contrast. There are often some limitations in traditional cross-line detection methods, such as Hough transform, template matching, morphological corrosion, linear fitting and so on. The result using linear fitting will be of a large deviation if the edge of a cross-line image is irregular. And the result using morphological corrosion will not find the cross-line center precisely if the contrast of the photo is not high enough. This paper obtains accurate deviation value through 3 steps. First, the picture collected by a CCD camera will be processed by color segregation algorithm. In this process, RGB data turn into CMYK data, and each color will be on a single picture. After that, a Laplace edge detection algorithm is improved by combining it with 2D Gauss filter. This improved Laplace edge detection algorithm has a better noise suppression effect, which means it is even less likely to judge noise as the edge of a graph. Finally, target searching algorithm based on rhombus matching is used to figure out the center of cross line. The average absolute error from 2,000 simulations is 3.192 pixel, which shows that the algorithm in this paper has a high accuracy. Traditionally, the overprinting error detection process is realized by examining the overlay quasi-identifier artificially. Fig. 1 shows 3 kinds of different overlay quasi-identifiers. If the deviation is larger than the line width, usually 1 mm, we support that the overprinting system is not working well. Also, the prints are off specification. A significant step of the detection using computer vision is how to get the data of channels C, M, Y and K according to the relation of RGB and CMYK. there is not a one-to-one correspondence. If we transform RGB to CMYK, there must be a replacement value for the black color. The replacement value can be figured out by C, M and Y channel. In fact, RGB color range is 0255, and CMYK color range is 0100. In actual situations, 4 different color crosslines may be in several kinds of states. The 4 crosslines can be separated from each other. And it can be that 2 crosslines are overlapped and another 2 is separated. Or 3 crosslines are overlapping. All in all, the overlapping relation is complicated. Fig. 3 shows the flow of this method. Now, we will solve the problem of how to find the crossline center by an improved Laplacian edge detection algorithm. The 2D Laplace transform is based on 2D gradient. 2D Laplace transform is usually expressed by a convolution of a matrix and a Laplace core. Actually, we will figure out the difference value between the value of a certain pixel and the neighboring horizontal and vertical pixels. Traditional Laplace edge detection uses the location of 0 point or the convolution result to find out the edge of figures. This method may take noise point as an edge with high probability. It is because that Laplace operator is not of the feature of smoothing the picture, which is available for Sobel operator or Pruitt operator. The time complexity of the algorithm is high, because it requires 2D convolution. We can optimize the algorithm by turning the 2D convolution into 1D convolutions. The process is as follows. Some scholars propose an approach to solve the problem. First, we need to judge which overlapping relation the crosslines are in. And for a certain relation, we use a different threshold to divide the picture. As we learned, there are 5 different color overlap, so we need 4 threshold values. This method requires a high color precision, and how to judge which color relation the crosslines belonging to is difficult. Based on the center point of crosslines of different colors, we can figure out the error of the overprinting system. If the location of the 4 centers is at the same point, the printing system is working well. If it is not the same, we need to calibrate the reference frame of the nozzles. In fact, this process is performed by computer. This paper improved the edge detection algorithm in overprinting calibration. According to the results in experiment, the algorithm in this paper is of a higher precision. Using this method can improve the quality of color printing. However, compared with traditional methods, this algorithm requires more matrix operations. This is not conducive to real-time monitoring at printing time. One possible solution is to make use of GPU or FPGA to speed up the process. And this is a further study issue. That is all my presentation. Thank you for your attention.
Hi everyone, my name is Dr. Renan Krishna and I work at Interdigital Europe in London. I will be presenting my joint work with Dr. Roger Beek-Vinas of the UPC Barcelona, titled Requirements for Deploying IP and ICN Network Stacks on a Common Physical Infrastructure. So let's start with a brief overview of ICN, which stands for Information Centric Network. This figure shows the ICN-based RIFE architecture used in our work. RIFE, which stands for Architecture for an Internet for Everybody, was a Horizon 2020 EU project. The system architecture shown aims to replace the network of an individual network operator so as to improve the IP-based services that it offers to its customers. The architecture does not require any changes to the existing IP user equipment connecting to the operator's network or to the IP routers/gateways of other interconnected operators. This is achieved by combining an ICN, which forms the core of the RIFE network, with a set of network attachment points, NAPs for short, which reside at the periphery of the RIFE network, serving as gateways between the IP and ICN worlds. Unlike the IP-based network layer, where machines are addressed by IP addresses, an ICN network layer, content in the form of named information items is addressed instead. This publish-subscribe architecture implemented in a software called Blackadder is facilitated by three core functions. A rendezvous function, RV for short, that matches publisher and subscriber nodes. A topology manager function, TM for short, that calculates paths between the various nodes and encodes them into forwarding IDs. And a forwarding node function that allows data items to be forwarded in the network based on the forwarding IDs. Now let us take a look at the deployment of IP and ICN network stacks over a common physical infrastructure in the lab and in the field. Two experimental facilities were deployed, one in a lab in Barcelona shown on the left and one in the field in Tarragona shown on the right. The Barcelona lab deployment was a partial reproduction of the Tarragona's facilities. The lab deployment was hosted in a laboratory of the Computer Architecture Department of UPC Barcelona. The Tarragona field deployment was a production network with 40 end users in several villages and towns surrounding the city of Tarragona and the city itself. Both deployments were integrated in the Goofy.net network and had internet access through optical fiber connections. Additionally, the Tarragona deployment had 2 satellite links provided by Avanti Communications Group. The organization of the network from the operator's perspective was as follows. To keep our deployment simple, the ICN software that we used only supported static network topologies, and at the physical network layer, we just used Wi-Fi in infrastructure mode. There are 2 types of nodes. A node is a geographical location with network equipment, the supernodes and the end nodes. The nodes are connected to each other through links. Topologically speaking, the supernodes are the nodes with more than one link to other nodes. That is, they extend the network, while end nodes are just linked to one supernode. That is, they are leaves in a graph. The links between supernodes are point-to-point links, usually built with highly directive antenna forming the backbone network. The links between end nodes and their supernodes are usually point-to-multipoint links built with sector antenna, also referred to as access points, or APs for short. This figure shows generic supernode. In addition to the directive and sector antenna, its main components include a core router, an unmanaged switch, and a number of ICN computing devices described in Table 1 of the paper. It also shows the interconnection links for transit or peering. Now let us look at how the 2 network stacks, IP and ICN, were organized on the physical infrastructure that we have just described. Consider this figure where the 2 stacks that we ran in parallel over the common physical network are shown. Note that we needed dual stack because ICN itself was not yet stable enough, and so we wanted to ensure that we had a backup network. This ICN stack shown on the left was used to carry the user's traffic, which was only IP traffic, although the same setting allows for other ICN traffic such as HTTP and constrained application protocol. Additionally, ICN signaling traffic was also carried over the stack. The IP stack was used to carry the management traffic of the network operator and optionally the user's traffic. This user traffic could be switched by the operator to the IP from ICN stack and vice versa. The IP stack was also used as a backup to access the ICN devices. We now identify the following 6 problems that needed to be addressed to enable a successful deployment. The basic first problem was that the deployment network architecture had to be designed to facilitate an error-free and easy-to-debug running of the ICN software. The deployment that followed this design had to include a suitable topology and a suitable configuration of the network infrastructure. The second problem was that the ICN and the management IP networks needed to be isolated from each other using techniques that facilitated an error-free deployment. The isolation is required not only to prevent the 2 networks from interfering in each other's functioning, but also to have an ability to identify the network from which a problem originates. Moreover, such an isolation enables a systematic allocation of resources such as ports, interfaces, etc., and simplifies the initialization scripts. The third problem was that we needed a way to deal with unpredictable emergent behavior during the initialization of the ICN network. The emergent behavior is a consequence of the way the configuration of the two stacks interact with each other. Often, these behaviors are hard to predict prior to a deployment. Some examples of such emergent behavior that we had to face in our deployment include loops involving broadcast/multicast MAC frames circulating in the various VLANs led to a complete network meltdown, with SSH access becoming impossible. As a result, we were unable to even run our scripts to deploy the ICN network. Low ICN throughput of 0.5 Mbps to 1.5 Mbps rather than the expected value of around 20 Mbps with TCP traffic was observed. Thus, we needed a way to deal with this non-deterministic behavior of the interaction between the operator's network providing IP-based management services and the ICN network. The fourth problem was that we needed to develop a workflow to coordinate between the network operator and the ICN deployer to deal with debugging problems that arose out of the unpredictable emergent behavior of running ICN. Often the process to deal with this behavior can be tedious, time-consuming, and error-prone. In addition, the deployed equipment was a 100-kilometer drive away, and a misdiagnosis of the causes for the errant behavior could result in a waste of time, effort, and money. The fifth problem was that the ICN network needed to be monitored to ensure that no component had crashed. To respond to a crash, coordination was required between the remote deployer in London of the ICN network and the local operator in Barcelona of the physical infrastructure. Similarly, the ICN network needed to be monitored for performance. To respond to performance issues, again, coordination as described above was needed. Finally, the sixth problem was that we needed a way to ensure that the real-world users could have access to the internet even when the ICN network was stopped for debugging purposes. Techniques were needed to achieve a switch between the IP and ICN networks such that the user's experience is not disrupted and at the same time is easy and convenient for the network operator. So let us examine the solution to each of these problems in turn. As a reminder, the first problem was that the deployment network architecture had to be designed to facilitate an error-free and easy to debug running of the ICN software. Our solution was as follows. In our deployments, the ICN functions NAP for network attachment point and FWD for forwarders were each implemented by an independent computing device to enable an easy isolation of problems such as software crashes, performance issues, misconfiguration of hardware, software, etc. This figure shows the ICN computing device's wiring. The RV for rendezvous and TM for topology management functions are performed by another computing device called RVTM. Note that there is one RVTM per deployment. Its first Ethernet port is attached to the switch, and the second to the third port of the forwarder. There is one NAP for each supernode with end nodes. Each supernode has a forwarding function which is performed by the computing device called the forwarder, or FWD for short. The first Ethernet port of the NAP and the forwarder is connected to the switch, and the second port connects them to each other. The second problem was that the ICN and the management IP networks needed to be isolated from each other using techniques that facilitated an error-free deployment. The solution to the second problem was as follows. Consider this figure where we show the organization of VLAN tags, bridges, and physical ports in the router on supernode 1 with simplified wiring. We just show one directive antenna and one access point. We isolated the ICN network and the IP-based management network into separate VLANs. The VLANs were named so that they were semantically meaningful. For our deployments, the semantic structure was used to identify the network, that is IP or ICN, and the nodes and interfaces involved. Each point-to-point link had two VLANs named X, Y, Z, where X was 1 for IP network, X was 2 for ICN network, Y was the lower supernode number, Z was the higher supernode number. The supernodes themselves were numbered from 1 to 6. For example, a point-to-point link between supernode 1 and supernode 2 will have two VLANs, VLAN 112 for the IP network and VLAN 212 for the ICN network, as shown in this figure. Each point-to-multipoint link had only one VLAN 1A. A equals 1 for access point 1, A equals 2 for access point 2, and A equals 3 for access point 3, etc. The VLAN 10 was reserved for management and had a scope that was limited to within a supernode. For more details about the semantics of our VLAN naming, please consult the paper. An example of how we organize the bridges to switch easily between IP and ICN networks is also shown in this figure. The user traffic is sent and received on the physical port P6 in the figure via the sectorial antenna of the access point and is passed on to the sub-interface corresponding to VLAN 11. As shown, this is the traffic that can then be switched either to the bridge BR11, resulting in the user network connecting to the IP network, or to bridge 21, resulting in the user network being connected to the ICN network. In this way, we were able to provide customers with highly available internet services even when the ICN network was being debugged for crashes or performance issues by associating a user equipment to the ICN or the IP network at the access point level. We now discuss the causes of the emergent behavior described as problem 3 in the previous slides and outline the general techniques and processes that practitioners can adopt to run ICN and IP-based networks over the same infrastructure. There were two issues that we solved. Issue 1, emergent behavior caused by the default settings of the software that were only appropriate for an IP and not an ICN network. Examples of default settings optimized for an IP network include default forwarding rule in OVS switches, default Linux settings where the kernel offloads TCP segmentation to the NIC for better IP network performance. These default settings had to be manually tracked down and switched off. The second issue was difficulties in debugging emergent behavior during deployment caused by an incomplete capture and enforcement of the precedence relations between the configuration of the network operator and that of the ICN deployer. To deal with the unpredictable emergent behavior during initialization due to the interaction between ICN software and the IP software, we generated initialization schedule from precedence constraints using standard techniques and algorithms. As a reminder, the fourth problem was that we needed to develop a workflow to coordinate between the network operator and the ICN deployer. The fifth problem was that the ICN network needed to be monitored to ensure that no component had crashed. The sixth problem was that we needed a way to ensure that the real-world users could have access to the internet even when the ICN network was stopped for debugging purposes. The solution to the fourth, fifth, and sixth problem was as follows. By representing the deployment infrastructure as code accessible to both the ICN deployer and the network operator and properly versioned, we were able to use the code as the interface between the ICN deployer and the network operator. All the necessary configuration of various software components, network interfaces, SDN switches being used for both ICN and IP were initialized by this code. Thus, the code became both the documentation of the configuration as well as the schedule of redeployment in case of crashes, performance issues, etc. Now let us look at the requirements that can be used by future projects to organize their deployments. Requirement 1. Translate novelties of ICN/alternative architecture into familiar configurations for the network operator. A deployment network involves many network technicians who might be unfamiliar with experimental architectures and may be skeptical about using them. Therefore, we suggest that the instructions given to the technicians for deployment must translate the novelties of an architecture into configuration techniques that they already know wherever possible. The tools developed should have an interface that supports these configuration techniques. In our case, this meant providing the network operators technicians with semantically meaningful scheme of VLAN tags and allowing them to easily switch between VLANs. This switching of VLANs by the technicians translated into switching between IP and ICN at the deployer's level. Requirement 2. Use precedence relations as a centerpiece of a strategy to deal with emergent behavior. In a deployment network, prolonged network downtimes are unacceptable to the customers. However, since ICN/alternative networks are not as highly engineered as the IP network, unpredictable emergent behavior that degrades the customer experience is inevitable. Therefore, debugging emergent properties in a systematic way using precedence relations should become the centerpiece of the deployment workflow. This means that the deployment tools should be centered around generating an appropriate initialization schedule from those precedence relations using techniques such as topological sort, critical path, etc. Requirement 3. Represent infrastructure as code. The entire deployment and its schedule as generated above should be captured in code that is supported by tools. This code then becomes the interface between the deployer and the network operator. Requirement 4. Retain IP as the fallback network. Live deployments of IP networks are highly engineered to optimize for an acceptable user experience. However, ICN/alternative networks will inevitably be not as robust and might fail from time to time. Therefore, it is highly recommended that tools should provide an easy way to switch traffic between IP and ICN alternative networks to deal with unforeseen problems in the ICN/alternative network. So as a conclusion, we hope that the general requirements presented in this paper will prove useful as constraining guidelines to develop tools for ICN and other alternative network layer deployments and complement the ongoing discussions within the Information-Centric Networking Research Group, ICNRG, of the Internet Research Task Force, IRTF. Additionally, we hope that this paper contributes to a set of best practices for the development of tools that are useful at the lowest level of abstraction for designing an internetwork.
Professor, College. My name is Đoàn Thanh Xuân. Supervisor is Dr. Nguyễn Đức Toàn. Today, I would like to present you the result obtained from our study, Pure Network-Based Approach to Achieve Always Best Quality Video Streaming. My presentation consists of 5 parts. Firstly, I will introduce the problem to be solved in this research, and in the second part, I will discuss related works. After that, I will present the detail of our proposal. Also, I will explain how the proposed mechanism has been evaluated. Finally, I conclude our work in the last part. Firstly, let's go to the first part named Problem Statement. Generally, video streaming has to compete with other applications, especially TCP-based one. As a result, bandwidth competition causes the video quality to be reduced. We did a simple experiment to confirm the mentioned problem. As shown in the figure on the left, the video bitrate reduced from 8,000 kilobit per second to 4,000 kilobit per second when there is no bandwidth competition occurs. The download file application, which competes bandwidth with the video streaming application, also be affected. The duration to download a file increased from 8.48 seconds to 17.29 seconds. There are related works have been proposed to improve video streaming quality. It is clear that to study the user experience directly to the most is the most strict and effective way to improve quality of experience. However, these methods may violate the user's privacy. Other researchers focus on improving video streaming application on either server side or client side. The approach is generally lack of the network view, hence it meets difficulty in solve the problem with quality of experience fairness among devices on the network. There are also several researchers suppose methods using network information. Many of them use SDN technology since the SDN controller knows the network wide and can control the network with ease. Hence, it potentially allocates a suitable bandwidth for each connection. The problem is that the SDN controller only works with SDN switch. It does not communicate with the host. Therefore, the SDN controller is unable to understand the host requirement. Our work will address the issue. Different from other existing researches, we propose a pure network-based mechanism to control the video streaming quality. The goal of our work is to find a mechanism to maintain the best quality of video streaming in the case of bandwidth competition. For this purpose, several objectives are needed. The proposer must understand the behavior of video streaming application inside the network. The second requirement is the proposer must be able to control the network programmatically. To collect the necessary information, application behavior must be studied. For information of video streaming, we have studied required bandwidth for each video resolution and video segment requests such as interval, video resolution, network estimation duration, and segment download duration. For information of 5 download application, we study download file duration. After the duration between two consecutive GET requests has been studied, the video streaming behavior within the duration is modeled as illustrated in the figure. The figure shows that delta t0 is the duration between two consecutive GET requests. Within delta t0, delta t1 is the duration for the client to download the segment. The delta t3 is the duration for the client to detect connectivity condition. The delta t2 is the duration that the video client may not consume the network bandwidth. In this work, we consider the scenario described in the figure. It is assumed that the bandwidth competition occurs after the client sends requests for the highest video quality. The duration of file downloading is assumed to be not too long. However, the proposed mechanism could be applied repeatedly for long-duration cases. Due to the native TCP congestion control or application, we have to share the available bandwidth fairly. As mentioned in the problem statement section, the video client may have to request a lower video resolution if the bandwidth is lower than the threshold. Also, the duration to download file is longer. The proposed algorithm to control network in case a bandwidth competition is given in the figure. While video is streaming from the video server to the video client, the module written in Python is to monitor video segment requests from the video client. When the maximum video resolution has been requested, the module to handle bandwidth competition is invoked. The module bandwidth competition handler takes the models of application behavior as the input to translate into network configuration to control the network in 3 consecutive GET requests. The mechanism of the bandwidth competition handler is as follows. After the video client sends the GET request for the maximum resolution, it is necessary to provide enough bandwidth for the video client to download the segment. In this duration, the bandwidth for the other application will be limited. Once the video segment is downloaded, the bandwidth for the video application can be reduced. This duration is an opportunity for other applications to have maximized available bandwidth. The bandwidth allocation for the video application must be increased before the client starts detecting network condition. That means bandwidth for other applications must be reduced. Here we explain the detail of how our proposed mechanism is evaluated. The experiment topology is given in the figure. As shown in the figure, 3 hosts emulated by Mininet connect to a real server via an emulated switch. The interface Ethernet 0 of the host H1, the interface Ethernet 0 of the host H2, and the interface Ethernet 0 of the host H3 are connected to port 1, port 2, port 3 of the switch S1 respectively. The bandwidth between H1 and S1 is B11. The bandwidth between H2 and S1 is B12, and the bandwidth between H3 and S1 is B13. The bandwidth between S1 and the server is BSS. Each of these bandwidth can be set individually to any values. Initially, all of them are set to 10 megabit per second. To stream video, the video content is put into a web server. Then video streaming client connects to the video via HTTP protocol. The video used in the experiment have a characteristic as given in the table. The procedures of the experiments contain 10 steps. 1. Start Mininet tool to create a network with custom topology. 2. Start BWM NG tool to observe the receiving throughput of host H1, H2. 3. Start sniffer program. 4. After 2 seconds, start streaming client on H1. 5. Monitor GET requests. 6. Start download file on H2. If the first GET a resolution of 1920 and 1080 pixels detected. 7. Reduce bandwidth for file download in a period of 4 seconds. 8. Increase the bandwidth for file download. Reduce bandwidth for video in the period of 9 seconds. 9. Increase bandwidth for video. Reduce bandwidth for file download. 10. Repeat step 7 until the file download ends. The experiment was repeated 20 times. The obtained result showed that the video quality was not reduced and the average file download duration was 15.5 seconds. The left figure and the right figure compare the obtained result in 3 scenarios. Scenario A, displayed by the darker blue bar, stable state. Scenario B, displayed by the red bar, bandwidth competition without our proposal. And scenario C, displayed by blue bar, show that our proposed mechanism helps to maintain always the best video quality to the client, even in case of bandwidth competition. The right figure shows that our proposed mechanism also help the competitor application to have a faster connectivity than that when our mechanism is not applied. Especially the duration to download file was reduced more than 10%, from 17.29 seconds to 15.5 seconds. In conclusion, the goal of the work has been accomplished. The quality of video streaming in the proposed mechanism has been maintained. Proposed mechanism has been implemented on the real task. The improvement introducing file download duration were 1.79 seconds, 10.35% compared to the case of bandwidth competition. In the future, we will conduct more experiments in variety scenarios. Diverse scenarios will be explored. More clients participate in the network. Different types of video players and video streaming mechanism. Study bandwidth competition under different congestion control algorithms. Thank you for listening.
Hello everyone. I'm very happy I can sit here to share my work to you. The title of my paper is CNN-based book cover and back cover recognition and classification. Now, I will report on my work from 4 parts. For the first part, it is project overview. With the development of Internet, the printing and publishing industry is also moving in the direction of digitalization and network. Among them, bulk digitization is an important part. The rapid development of machine learning and the rapid naturality of image recognition and classification technologies have greatly improved the efficiency of the bulk digital entry system. I have read a lot of literature and found that there are already many mature algorithms and image classification models in the field of computer vision and machine learning. However, there are still relatively few studies on applying these algorithms to the recognition and classification of bulk covers and back covers. As an important part of the national economy and an important supporting industry, printing and publishing industry is closely related to the development of national economy. In this paper, we connected a large number of bulk datasets, and we built a set of image classification models based on CNN to identify and classify the cover and back cover of books. Through a lot of training and testing, we have generated a set of CNN models that can effectively identify and classify the cover and back cover of books. For the second part, it is image recognition classification model. This paper builds a set of image classification models based on the research of machine learning and neural network. First, we connected a large number of images of cover and back cover of the book and processed these images as a dataset, then built a set of neural networks. Use these datasets to iteratively train and predict the network. And finally, generate a training model that can effectively identify the book cover and back cover to achieve the classification effect. The recognition accuracy of the image classification model largely depends on the quality of the dataset. For the design of neural network recognition system, it is very important to have a sufficient amount of labeled training data, and the data obtains as many complex environmental changes as possible. The datasets used in this article mainly comes from two major e-commerce platforms of Jingdong.com and Dangdang.com. The datasets connected 3,600 images containing back cover and back cover from online shopping malls. These back images have 3 different kinds of environment, including main picture sense, multi-picture sense, and publishing house sense. The main picture sense is a single cover or back cover picture. The multi-picture sense is a picture that may contain more than one book. The publishing house sense is the cover or back cover of the book containing the content information recommended by the publisher. In deep learning, convolutional neural network is a special deep neural network often used in the field of computer vision. In the convolutional neural network, the input layer refers to the input image data, which is generally stored in the form of mainstream matrix. The dataset we connected contains pictures of various signs. To facilitate the calculation, we processed the training set and unified the size of training set pictures to 200 multiplied 200 pixels. In the conversion process, the conversion canal extracts image features by conversion calculations operations on the import layer image. When building the neural network, we used 2 convolutional layers here. The activation function is a processing function added to fit the input-output relationship of nonlinear characteristics. In CNN, each convolutional operation process of the conversion canal is to sum up the products of various positions in the template, import the calculated value into activation function, and then use the output value as the conversion result. The polling layer compresses the input feature map to make the feature map smaller and simplify the computational complexity of the neural network. On the other hand, the main purpose of feature compression is to extract the main features corresponding to the 2-layer convolutional layer. We use a 2-layer polling layer, and the method used by the polling layer is maximum polling. The fully connected layer contains input nodes and output nodes. The input nodes receive the output date of the previous layer. After calculation, The result is passed to the output nodes, and the output nodes transmit the data to the next layer of neural network, thereby passing the output value to the classifier. CNN model. CNN is composed of input layer, conversion layer, activation function, pawning layer, and finally connected layer. The most prominent advantage of CNN is high-speed parallel computing and processing speed not influenced by the size of image, so it is convenient for hardware implementation. In addition, the neural network constructed in this paper includes 2 convolutional layers, 2 pawning layers, and 3 fully connected layers. The structure of the convolutional neural network is shown in the following table. The third part is model assessment. Model training is divided into several stages. First, the input layer obtains the processed 24-bit JPG format RGB 3-channel image. After the first convolution operation, the output image is a 16-channel 200 × 200 pixels image. Then we perform the first pawning operation. The pawning layer uses a 2 × 2 max pawning and outputs a 100 × 100 × 60 matrix. Next, it is the second convolution operation. After that, we can obtain a new matrix of 100 × 100 × 60. After all this, it is second pawning operation. The image is reduced to 50 × 50 at this time. At last, we have 3-4 connections options, and the input nodes the input nodes here are separately 40,128 and 64. The number of output nodes of the last one is 2. These 2 nodes correspond to 2 output values, including the property of the back cover and back cover. The following picture shows the recognition results. In order to improve the classification effect of the convolutional neural network model and achieve good predictions on new data, the data set is divided into 3 subsets: training set, validation set, and test set. Because the data set is relatively scarce, it cannot open and it cannot copy with all situations, but we can simulate more training data by increasing the number of training. In the experiment, different training times and learning rates were set for the constrained model to observe the experimental data. For each CNN model, a multi-scale simulation model is employed to avoid overfitting that is usually caused by limited training data. A too high learning rate will increase the risk of overfitting, and a too low learning rate combined with relatively scarce training data may cause the learning model to fail to learn specific feature values. It can be seen from the experimental data that when the number of training results is 3 and the learning rate is 1000%, the accuracy of the test reaches the highest when the number of training is 5. The accuracy reaches the highest and for the last part, conclusion, we built a set of convolutional neural networks through the research of deep learning to identify and classify the cover and back cover of box. By revising the different parameters in the construction model, a relatively good accuracy rate has been achieved, which provides a certain reference from bulk identification and classification. Due to the limited ability of the author, I failed to provide a more perfect solution for bulk classification. Machine learning is often inseparable from big data. My next step is to improve the bulk classification dataset and classify the dataset according to the bulk categories. Thanks for watching.
Hello everybody. It is my great honor to display our paper. Our paper's name is a case study of linguistic research methods in the age of computing. This is our 3 authors of this paper. And I will introduce our paper as follows. Firstly, linguistics. As we know, linguistics is a scientific study of language and involves an analysis of language form, language meaning, and the language in context. Linguistics traditionally analyzes human language by observing and interplaying between sound and meaning. The study of language meaning, on the other hand, deals with how languages encode relations between entities, properties, and other aspects of the world to convey, precise, and assign meaning, as well as manage and resolve ambiguity. Well, the study of semantic typically concerns itself with truth conditions. Programmatic deals with how situational context influence the production of meaning. A very important research band in linguistics is grammar. Grammar is a system of rules which governs the production and the use of utterance in a given language. These rules apply to sound as well as meaning and include conventional subsets of rules. Modern theories that deal with the principles of grammar are largely based within Chomsky's framework of generative linguistics. As a very important branch in social scientifics, linguistics also deal with the social, cultural, historical, and political factors that influence language, through which linguistic and language-based context is often determined. Research on language through the sub-branches of historical and evolutionary linguistics also focuses on how languages change and grow, particularly over an extended period of time. The Tibetan-Burman language are non-Semitic members of the Sino-Tibetan language family. Over 400 of which are spoken throughout the highlands of Southeast Asia, as well as certain parts of East Asia and South Asia. The name differs from most widely spoken of these languages, namely Burmese and Tibetic language. This language also have extensively lateral traditions, dating from the 12th and 7th centuries, respectively. Most of the other languages are spoken by much smaller communities, and many of them have not been described in detail. During the 18th century, several scholars noticed parallel between Tibetan and Burmese, both languages, with extensive lateral traditions. Most of the Tibeto-Burman languages are spoken in accessible mountain areas, and many are unwritten, which has greatly hampered their study. It is generally much easier to identify a language as Tibeto-Burman than to determine its precise relationship with other languages of the group. And in this paper, we use a software named SetSpace as a tool to do bibliometric analysis on Chinese, Tibetan, Burman language research. With the development of technologies such as computers, artificial intelligence, and big data, new research methods have emerged into the traditional social science. With the help of new research methods, the efficiency and accuracy of quantitative analysis can be improved, which is helpful to improve the research efficiency and the display research trends. Bibliometric analysis is to use mathematical and statistical methods to quantitatively analyze a given knowledge area. Through a quantitative analysis of literature in a certain field, basic information such as research overview, research hotspots, and research distribution in the field can be obtained. This information has good reference value for researchers to sort out the research context of the field and discover the research innovation points in the field. SetSpace is a visual bibliometric analysis software developed by the team of information visualization expert Chen Chaomei. This software can perform keyword clustering analysis of scientific literature, also cooperation network analysis, and so on, and display the analysis results in visual forms such as timeline and knowledge structure map. At present, few scholars use professional tool software to carry out bibliometric analysis of Tibetan Burman language research. And this article combines the needs of Tibetan language research and characteristics of SetSpace visualization tools, and uses SetSpace to do quantitative analysis and visual display of Tibetan Burman literature. Let's see something about SetSpace. The SetSpace is a freely available computer program written in Java for visualizing and analyzing literature of a scientific domain. A knowledge domain is broadly defined in order to capture the notion of a logical and cohesive organized body of knowledge. It may range from specific topics such as post-traumatic stress disorder to fields of study linking clear out boundaries such as the research on terrorism or regenerative medicine. SetSpace takes bibliographic information, especially citation information from the Web of Science, and to generate interactive visualizations. Users can explore various patterns and trends uncovered from the scientific publications, and develop a good understanding of scientific literature much more efficiently than they would from an unguided search through literature. The full text of many scientific publications can be accessed by a single click through the interactive visualization in SetSpace. At the end of a session, SetSpace can generate a summary report to summarize key information about the literature analysis. And this is an image from the slide space, and this is due the clustering by this software. By using set space as a tool, we can get some conclusion through the Tibetan language research in China. The analysis include the author, the publishing organization, and the concurrence of keywords. The conclusions are drawn as follows. First, we can see that new research methods such as computers, artificial intelligence, and big data can improve the efficiency and accuracy of quantitative analysis, help improving research efficiency, and show research trends, which is very important to researchers to get the hot spot in field. Second, the cooperation method is simple. Most of the authors in the field of Tibetan-Burman language research in China are independent researchers, and the existing cooperation relationships are mostly teachers and students or colleagues. Although this kind of cooperation has cultivated new force for Tibetan-Burman language research, but at the same time, its lack of research and cooperation within the field and cross fields, and there are certain limitations in research method and research series, which is not conducive to the creation of academic innovations. Third, there is certainly lack of new research hotspots in the Tibetan-Burman language field, and there have been few Tibetan-Burman research papers in recent years. We can see that in some years there are only 8 or 9 papers in a whole year to present in China. For research methods lack innovation, the existing Tibetan-Burman language research is mostly based on traditional linguistic research methods, and there is no combination of information and intelligent research methods in the Internet age. The old researchers still use their old methods to do research in the Tibetan-Burman language field. Now this is our briefly introduction to our paper. Thank you for watching.
Good morning. I am Yanji from Beijing Institute of Graphic Communication and very honored to share my study on an analysis model of automobile running state based on neural network. Next, I will give you an introduction. This talk is mainly divided into the following three aspects to explain: what is it, why and how to do it. What is it? Automobile operating conditions refer to the working conditions during automobile transportation. Let's enjoy a video to feel the EPA working conditions endurance 509 kilometers. Why is it? European and American countries have also discovered many deficiencies in NEDC operating conditions in their years of development and practice. In order to solve the problem, European and American countries have begun to adopt the World Light Vehicle Test Cycle. But even the WLTC working condition is not in line with reality for our country. The two most important characteristics of this operating condition, idling time ratio and average speed, are quite different from the actual driving conditions of automobiles in my country. On the other hand, my country has a vast territory, and the development level, climatic conditions and traffic conditions of each city are different, which makes the characteristics of the driving conditions of vehicles in each city have obvious differences. How to do it? Two-stage clustering is mainly used for the construction of automobile driving conditions. The method to build a model. First, use the self-organizing map neural network to perform the initial clustering of the process data to obtain the number of clusters and cluster centers. The data set for this experiment comes from the EAI Cup Math competition for time-missing data. If a car enters multiple high-rise building intervals and is covered by high-rise buildings, or a car enters a tunnel, it will cause the loss of the car's GPS positioning, resulting in data loss, that is, the problem of discontinuity of data. Segment the data fed at time breakpoints to ensure complete driving segments. For abnormal acceleration and deceleration data, under normal circumstances, an ordinary car changes from 0 to 100 km per hour. The acceleration time should be greater than 7 seconds, so some cases of excessive instantaneous acceleration in the data set can be regarded as abnormal data. For abnormal deceleration data, under normal circumstances, the maximum deceleration of emergency braking is 7.5 to 8 meters per second too, so it exceeds. Data in this range can also be regarded as abnormal data. After removing the above abnormal acceleration and deceleration data, it will be created in the data set. A breakpoint in time is reached, so the segment data is updated. For long-term idling data, there is a long-term parking during the driving of the car, such as parking without stalling, etc. In the face of this situation, they are handled according to idling speed, but when a period of idling time exceeds 180 seconds, we will treat it as an abnormal number. Data processing, and calculate according to the maximum value of 180 seconds. A two-stage clustering model based on SOM and K-means models is used to complete cluster analysis. SOM has the nature of automatic clustering. In the first stage, input pre-processed data and use SOM to obtain the initial cluster number K and center Z. This model solves the shortcomings of previous clustering models that the number of clusters needs to be artificially specified during clustering and reduces the complexity of the calculation process. In this stage, further clustering is performed, and the number of clusters K and center Z obtained in the first stage are used as the initial input of K-means, and the specific clustering information is finally obtained. SOM neural network model is mainly able to represent high-dimensional space and low-dimensional space, usually one-dimensional or two-dimensional, data method. The process of reducing the dimension of a vector is called vector quantization. In addition, the SOM network, the topological relationship of the original data can be maintained. The self-organizing mapping neural network can map high-dimensional data through the neural network according to the sample characteristics and internal laws to low-dimensional space, achieve the purpose of dimensionality reduction and clustering. The average of 15 indicator parameters is calculated, and the traditionally calculated driving conditions are constructed from the two-segment clustering method. The operating conditions are compared with the driving conditions constructed separately using the k-means method. The results show that the average relative error obtained by the two-segment clustering method is small, only 3%, and the error of k-means clustering method is greater than 5%. Therefore, the two-segment clustering method perfectly avoids the k-means clustering because the dataset is too large, resulting in the initial convergence difficulties of the model run. There may be local optimal solution of the problem, and the model built by k-means represents the driving conditions closer to the experimental data to better reflect the actual road traffic conditions of the city in which the car is located.
Fusion Bert and BiLSTM model to extract the weaponry entity. Weapon entity extraction is an indispensable link in the process of constructing weapon knowledge graph. In terms of entity extraction of weapons and equipments, a fusion model of domain, Bert model and BiLSTM model with embedded word vector and word composition rate vector is proposed to identify weapons and equipment entities. Let me start my speech from 4 aspects: introduction, model, experience, and conclusions. Part 1. Introduction. If the military build a knowledge graph in the field of weapons and equipment, then they will manage its weapons and equipment more efficiently. In other words, this knowledge graph helps the military analyze its compatibility and obtain more information on the weapons and equipment of competitors. There are a large number of unstructured tests containing weapon and equipment information on the Internet, which can be extracted to form a weapon and equipment knowledge graph. NER is an indispensable step in building a knowledge graph of weapons and equipment. So what are the foundations of the above work? In 2005, Xiang Xiaowen used the hidden Mark4 model to carry out the Chinese NER task. And then in 2011, Ju Jiupeng used the method of combining CRF and ROS to identify the space-named entities in the text. And then in 2015, Feng Yuntian used a CRF model to extract named entities from the military text. And then in 2016, Marade used the combination of BiLSTM and CRF to recognize biological named entities. In 2017, Zhang Hainan used a deep network to perform NER tasks on the People's Daily Compass. In 2018, the Bert model was proposed by Google. In 2019, Li Jianlong used a BiLSTM model to solve the recognition problem of the NER. And in the same year, Ji Xiangbing used the attention BiLSTM method. And in the same year, Wang Ziniu used Bert for the task of NER. Part 2. Model. This framework is based on the fusion of the Bert model and the BiLSTM model to solve the problem of NER in the weapon equipment. First, Bert language model on the largest scale military test and generates feature vector after encoding the test through the pre-trained Bert language model. Second, we use the virtual vector language model to train the word vector matricing, calculate the word composition rate in the test to form a word composition rate vector matrix, convert the test into a vector through the word vector matrix, and the word composition rate vector matrix. Third, BiLSTM model to obtain the feature vector. Fourth, The feature vector output by the BiLSTM model and the Bert language model are added to obtain the total feature vector. The last, the hierarchical entity extension is used to extract the total feature vector to obtain different types of entities. So why Bert is so strong? On the one hand, it encodes the text into vector with military semantic increase prime information and improve the model's ability to recognize weapons and equipment entity. On the other hand, second sentence get E1 to En vectors through word vectors embedding and position embedding, and the final feature vector T1 to Tn are obtained through the transformers layer. In more detail, it is attention mechanism that makes Bert have super ability. The first step is each vector passed through 3 different fully connected layers to obtain 3 vectors Q, K, and V. Then the second step is to obtain the vector Q, K, T. After matrix multiplication of Q and Kt, which represent the degree of correlation between words and the other words, the last step is to obtain the correlation degree vector between words by putting standard Q, Kt into the softmax activation function, and then the correlation degree vector should be multiplied by V to obtain the vector A1. That is to say, each word in the Bert model will take into account the semantic weights of other words in the sentence when encoding, so it has a strong coding ability. BiLSTM model can capture the bidirectional information flow of the text. In this model, the 2 directions of the information are connected. When traditional methods use only one fully connected layer for sequence labeling, so only one label sequence can be generated per sentence. There are often multiple types of named entities in a sentence, and different types of named entities may overlap entities. There are 2 types of labels in the paper, 0 and 1. A sentence will generate 2 line tag sequences. One sequence is responsible for extracting the beginning text of the named entities, and the other sequence is responsible for extracting the ending text of the named entities. Part 3. Experiment. The data comes from the test data on the ships and aircraft on the global military network website, and finally, 5,000 sentences are marked. Among them, 4,000 pieces are used as training data, 500 pieces are used as test data, and 500 pieces are used as validation data. The corresponding English abbreviation of entity categories are shown in Table 1, and the numbers of weapon and equipment entity catalogers in the corpus is shown in the table 2. To verify the expression of the model, the f1 value after the combination of operations P and the recall rate R is used to judge the pros and cons of the model. The calculation formulations is shown in the slide. When the names and catalogers of the predicted entities and the recall entities are the same, it is called the total number of entities. We carried out 5 experiments. Experiment 1 used the BiLSTM model with embedded word vector and word composition rate vector to perform named entities recognition task on the dataset, and the name of the experiment is denoted as BiLSTM-T. Experiment 2 used the Bert model that is pre-trained on the military test and has no hierarchical entity extension to perform named entity recognition task on the dataset. The experiment recorded as PRE Bert no hierarchical. Experiment 3 used the Bert model pre-trained on the military test to perform named entity recognition task on the dataset, and the experiment named is recorded as PRE Bert. Experiment 4 used Google's open-source Chinese PRE trained Bert model and BiLSTM model with embedded word vector and word composition rate word vector to fuse them on the dataset to perform the name entity recognition task. The experiment name is recorded as Bert BiLSTM-T. Experiment 5. The Bert model pre-trained on the military test and the BiLSTM model with the embedded word vector and word composition rate vector were used to fuse them on the dataset for name entities recognition task. The name of experiment is recorded as PRE Bert BiLSTM-T. We set 4 goals in the paper. Experiment 1 and 2 to verify the feature extraction ability and the transformer learning ability of Bert. Experiment 2 and 3 to prove that adding a layered entity extraction can more identify weapons entities. Experiment 4 and 5 to verify that Bert model pre-trained on the corpus of a domain is more suitable for named entities task than the pre-trained Bert model on the general domain corpus we set up. Experiment 3 and 5 to verify the of the BiLSTM model combining embedded word vector and composition rate vector. As shown in the slide, experiment 1 and 2 show that Bert has strong transformer learning ability and feature ability. Experiment 2 and 3 show that adding a layered entity extraction can extract a certain type of entity more accurately. Experiment 4 and 5 show that the pre-rating Bert model on the military corpus can learn more, and experiment 3 and 5 show that adding embedded word vector and composition word rate vector not only allowed the model to accurately more primary features. Part 4. Conclusions. We can obtain 3 points. First is the Bert model has strong transfer learning capability and feature extraction capability. Second is aiding a layered entity extraction can extract a certain type of the entity more accurately. The last is that the embedded word vector and word composition rate vector can increase the precision features of the domain, and the model fusion makes the models correct each other. Thank you for watching.
Ladies and gentlemen, good afternoon. I'm honored and proud to have the opportunity to speak at this meeting. Today, I'd like to present my paper, CSA Chinese Image Captioning based on Image Label Information. In the first part of the report, I'm going to begin with a detailed introduction to image captioning and related research work, and then propose a new model for the problems encountered in the research of Chinese image caption. We also conducted a series comparative experiments based on this model, and finally conclude that the CSA model is in Chinese image captioning is superior to other most advanced models. Next, we will discuss the above 5 abstracts in detail. First of all, let's learn about the introduction of image captioning. Image caption is an important work in the field of computer vision and natural language processing. It can create descriptive sentence according to the image content, which is an effective method to narrow the thick gap between low-level visual feature and the semantic information of the image. But currently, much of the image captioning work is concentrating on generating English sentence. Few image caption work conducted on Chinese sentence graduate due to the lack of dataset on image description labeled by Chinese. And up to now, there are 3 kinds of method to graduate image captions. They are template-based method, review-based method, and deep learning-based method, among which the deep learning-based method are the most advanced and achieve the best performance. On this basis, the BiLSTM proposed in this paper, which used the image label features abolting from the label prediction network to graduate descriptive sentence. Before introducing the model proposed in this paper, let's look at the research done by other scholars in the field of image captioning. With the development of deep learning, researchers have proposed image captioning method based on deep learning. In 2015, Venus proposed the image caption model based on convolution neural network and BiLSTM. The NSA model used CNN to extract the visual feature of the image. In 2015, Xu introduced the action mechanism into the model for the first time, which enables the model to capture the local information of the image. In 2016, Jia used the semantic information to graduate BiLSTM in generating descriptions. In 2017, Running applied reinforcement learning to model train of image caption. In 2017, Dai optimized the NSA model using condition gain, making the generated sentence more natural and diverse. In 2018, Edison proposed a combined bottom-up and top-down attribute mission, which enables the model to obtain image regions with semantics with predicting description, and the performance is further improved. The above-related work is all about the research on English image caption. The research on Chinese image caption is relatively few, and the quality of descriptions is need to be improved. In 2016, Ze Yu Liu fused the visual features and label features with BiLSTM in 4 ways to improve the effectiveness of the NSA model. In 2018, Wei Yulan used the top 10 image prediction labels to sort and select the generated sentence of NSA model, which makes the selected sentence closer to the label information and improves the image descriptive ability of NIC model. Based on the above research work and the current problems of Chinese image caption, we will first describe you the Image Label Prediction Network (FCPT), then introduce our proposed image caption generate CSE. In the dataset of image caption, each picture described by the file description sentence. Each sentence can vividly describe the content of the image. We choose the nouns, verbs, and adjectives in the sentence as the image labels. Firstly, we use Chinese word segmentations to sponsor to segment the words in the descriptive sentence and selectively retain the nouns, verbs, and adjectives according to the word frequently. Then we contrast a label vocabulary of the Riemann words and take the label information for each picture. Therefore, we can obtain the training data of label prediction network. The image label prediction network proposed in this paper consists of two parts. One is a feature extraction network based on CNN. The other is a phasor classification network, as shown in figure. The Chinese image caption model CSE proposed in this paper is composed of CNN and LLSTM. CNN is used as the encoder to extract emission convolution features, and LLSTM is used as decoder to decode the image convolution features to the target descriptive sentence. Specifically, LLSTM first accepts the image convolution feature and ignores the output at this time. Then, after inputting a start simple, start, and a predict label feature, LLSTM output a vector composed of the prediction probability of the word in the vocabulary and selects the word with the highest probability as the output. Then the word and the prediction label feature are used as the input of the next time, and the prediction is continued until the end simple. End is predict, and the overall structure is shown in figure. The encoder CNN in the CSE model is a natural network used to process grained data. CNN model consists of a series of linear or non-linear transformation models, such as convolution layer, point layer, and activation layer. Deep CNN model is generally used to extract image figures. After times of convolution, pulling more structure and more experience, with make breakthrough in image classification, object dictionary, and other visual text. The CNN used in the model is ResNet 152. ResNet 152 is the best performance of the ImageNet 2015 image classification computation. Next, we enter the introduction of the experimental part. First, let's introduce the dataset used in the experiment. The dataset used in this paper are Flickr 8K CN and Flickr 30K CN. Flickr 8K CN and Flickr 30 CN have been translated from English image caption dataset into Chinese by machine translation method. The Flickr 8K CN dataset contains 8,000 annotated image and 40,000 Chinese description sentence, as shown in Fig. The Flickr 30K CN dataset contains 30,000 annotated image and 150,000 Chinese description sentences as shown in Fig. In this paper, Flickr 8cn and Flickr 30kcn are segmented according to the data segmentation method used in captioning. Flickr 8kcn includes 6,000 training data, 100 verification data, 1,000 test data. Flickr 30kcn includes 28,000 training data, 1,000 verification data, 1,000 text data. The above table shows the results of macro precision, macro recall, and macro F1 different label prediction networks. FC1 represents the single layer, fully connected network. FC2 represents the two-layer fully connected network. FC3 represents the three-layer fully connected network. FCPT represents our purpose label prediction network. It shows that the purpose method can solve the problem of multi-layer label prediction network direction. But as a whole, the accuracy and the recall rate of label prediction network still have much room for improvement, which need to be further studied in the future. The proposed Chinese Image Caption Network CIC is compared with CNIC Immovable in RIFE and the Sentence Rearrangement MLP in RIFE. As shown in table, CIC also performs well on Flickr 13K data. The CIC process in this paper has achieved the best results on Flickr 8kcn and Flickr 13kcn due to the existing Chinese image caption model. Finally, I would like to make a conclusion with this presentation. We propose a label-based image caption model CIC in this paper. Firstly, a label prediction network is proposed to capture the image label features, which effectively solves the problem of network with the deepening of the number of label prediction network layers. Secondly, we present an LSTM actor in which image label features are input into the image caption network. However, the model proposed in this paper still has room for improvements. In the aspect of label prediction network, it will continue to improve the accuracy of label prediction network and try to use high-quality label features to graduate descriptive sentence. Okay, ladies and gentlemen, it has been my pleasure to give you my viewpoints on CIC Chinese image captioning based on image label information. Thank you very much for your kind attention. Ladies and gentlemen, good afternoon. It's a very great pleasure indeed for me to be able to attend this meeting. Today, I'd like to present my paper, Cross-Language Transforming the Patent Quality Evaluation Model based on Active Learning Data Extraction. My presentation will cover the following aspects: introduction and related research on patent quality evaluation, and then propose a new model for the problem encountered is cross-language transforming patient quality evaluation model based on active learning data extractions. We also conduct a series comparing experiments based on this model, and finally, conclude that the model in patient quality is superior to other most advanced models. Next, we will discuss the above 5 aspects in detail. First of all, let's learn about the introduction of patent quality. At present, China has become a major patent production country. As the number of patents has increased, the quality of patents has begun to draw people's attention. However, there are still some quality problems in China's patent. The increase in the number of patent applications masks the fact that quality of patent is low. At present, there is no clear evaluation method for Chinese patent. In the previous study, the actor constructed an English patent quality evaluation model PQE-MT using US patents that represent patent strings. On this basis, this paper introduced this model into Chinese patent through transfer learning and active learning, thereby reduce the workload of manual labeling. The evaluation results show that the method in the experiments has achieved a good migration effect. Before introducing the model proposed in this paper, let's look at the research done by other scholars in the field of patient quality. Due to the time-consuming and labor-intensive work of data labeling and scaling of high-quality label data, transfer learning has attracted more and more attention from the academic community. Bannon proposed a method of cross-language transfer learning due to the abundant data of English tagging. In 2009, Pan proposed to transfer the domain with training data to the domain with similar data distribution to greatly improve the learning effect by avoiding expensive data. In 2011, Xu used migration learning and mutex learning to extract and transfer useful knowledge from the data in the domain. In 2016, WSIS explains transfer learning and information about solution and discuss possible future research work. In 2017, Yoseki studied the mobility of deep networks. Based on the above research work and the concurrent problems of patient quality and the PQE-MT model, this paper used transfer learning and active learning method to further propose a cross-language transfer patient quality evaluation model based on active learning data extraction, and transfer the organized model to Chinese patients. The following article will introduce the model from these two parts. The MPQ-MT model consists of two parts: a quantity index model and a multi-text learning model. Multi-text learning includes text classification tasks and name entity recognition tasks. The overall model structure is shown in Fig. In the experiment, motion translations was used to translate the text part of the Chinese and English patients, and the patients' grades of some Chinese patients were marked. Through the transfer learning, the model was adapted to the index direction and the language phase of Chinese patient. Finally, the part shown by the dotted line in figure is selected for the migration of model parameters. Translate the English text patient USA English in the source domain dataset into Chinese text patient USA CH. Trained by patient USA Chinese, the Chinese patient quality evaluation model PQE-MT-CH based on the US patients. Phrase model PQE-MT Chinese without train layer. Let train set equal patient family CHN Chinese. Repeated equations n times. Use train set to continue training the model PQE-MT Chinese. Use the model PQE-MT Chinese to clarify and predict the simple set patient Chinese CHN. Consider the probability C1 and C2 of the two kangaroos with the highest predict probability for each sample. Obtain the set S of 100 samples with the largest uncertainty, that is the smallest C1 to C2. Remove set S from the sample set patient Chinese. Label the samples in the set S. Set S is added to train set. Return to the migrate model PQE-MT CHN Chinese. Next, we enter the introduction of the impairment part. First, let's introduce the dataset used in the impairment. The impairment used 29,167 US patients, of which the number of patients with different rating is shown in figure. There are 21,622 Chinese patients, 308 of which exist in the US patient dataset. 308 patients are applied in two countries at the same time. From a patient family and belongs to the same family. In the impairment, its scores in the US patient corresponds to the Chinese patient, so as to obtain the quality level corresponding to the Chinese patient. The accuracy recall F-score, accuracy micro-averaging, and micro-averaging used in text classification evaluation are used for evaluation. The conclusion process is shown in Formula 126. The experiment used 1768-dimensional Bert vector with 12-layer transformer and 12 metal head attention motions as the embedding layer of the model. When the accuracy rate of the verification set doesn't increase after 10 epochs, the training is stopped, and the best model parameters are obtained by a checkpoint. The final loss value of the model is the sum of loss value of the classification result and the loss value of the entity labeling result according to the weight of 3.1. The experiment gives according class weight to different kangaroos, so that the number of kangaroos and the weight of each kangaroo can to the same value, ensuring that better results can achieved in small kangaroos. Based on this, the above models are compared and tested to obtain the best sequence model, which is combined with quantitatively indexed model. The active learning processing is set up in 10 rounds. Each round obtains the top 100 data with the highest score for labeling, and finally obtain 1,000 label samples for further migration training of the model. Now let's talk about the model train results. The layer of the final PQEMT are shown in table. According to the structure of the network model, the experiment gradually frees the parameters of each layer at the bottom of the network, compares the effect of the migration model under the condition of training different network layer, and use the number of layers at the best effect as the final migration part. From the experimental results, it can be seen that as the low-level parameters of the network gradually freeze, the indicator of the train set showed a downtrend as a whole. The indicators of the text set, especially the macro average, have a processing of first increasing and then decreasing. In the final experiment, the parameters of the 2-to-2 layer of the model were frozen, and the layers 3 to 14 of the model were selected for the migration. In this paper, a model that only used the English text of Chinese patient without migration is compared with the 3 to 14 layers model with the best migration effect to observe the improvement of the model effect with migration learning. The results are shown in the above table. Compare the effects of random selection and active learning selection on the effect of model migration. Comparison of the prediction accuracy of the model in the two cases. Through the comparison of the two trend lines, it is found that active learning to select data has better results than randomly select data. The experiment used active learning to further expand the number of the label data. The experiments used the best migration part obtained in the preview article, that is, freezing the 0 to 2 layer of the network and select 3 to 14 layer as the emerging part. The above table shows the migration results of 2,208 Chinese patient data obtained after active learning expansion from the evolution indicators of the training set and the text set. In addition, the experiment used the Chinese text of the patient to conduct the environments in the same way, and the results are shown in the table on the right. Finally, I'd like to make a conclusion with this presentation. The advantage of this model lies in the use of migration learning technology and active learning to select the data to be labeled with the largest amount of information, thus minimizing the time-consuming manual labeling process. In the whole process, through experiments, the prediction effect of the model was gradually improved, and finally, the Chinese patient quality evolution model achieved good accuracy. At the end of experiment, the effect of transfer learning between Chinese and English was compared, and it was found that the result indicators were different, and the model learned different features. In the following work, I will combine the two language models and consider the different features learned, so that they can influence each other and improve the final results. Okay, ladies and gentlemen, it has been my pleasure to give you my viewpoints. Cross-language transforming the patent quality evaluation model based on active learning data acquisition. Thank you very much for your kind attention.
Hello everyone. The title of my paper is Construction of the Unsupervised Prose Text Emotional Lexicon based on Multidimensional Fusion. My name is Zhang Kai. My unit is Capital Normal University, Research Center for Language Intelligence of China. Affecting computing is an important tool for language processing and option mining. An emotional lexicon is the base of emotional computing, and the Prose account for the large property in Chinese teaching and application in China. I will introduce the content from the following 5 parts. There has been no defining conclusion on the defining of the prose. So far, it's difficult for prose to turn the category into the body, which is even more difficult in Chinese education. The number of the poems in junior high school Chinese textbook account for the half of the country, which is the most important part of the textbook selection. Senior high school Chinese textbook are composed of novels, dramas, poems, and essays. Prose is a literary genre with the ideals of the negative and excess feature. Comparing with the other literary style, prose is more complex and is the emotion compression is the particular program of the challengeable, which is a great challenge to the body of the prose text understanding. A good emotion lexicon is an indispensable foundation of the emotional analysis. This part, I will introduce the research status. Emotion directories can be divided into the genre affecting categories and the domain affected categories. At present, most genres affective categories are unconstructed manual. The more famous English emotion categories are the sentiment net, genre inquiry, and option lectures, which is the Chinese ones are HONET, DUITTR, and TUSD. The construction of the genre emotion categories manual announces words by the meaning of the synonyms, antonyms, and hypers relations between words. At present, there are relations with few standard Chinese emotion categories. There are 3 option emotion categories in Chinese information processing. By mining the relationship between the words through the semantic categories database, we can construct an emotion category. Raw extract the positive and negative affective words from the word net by means of the semantic supervised learning method and by giving the positive and negative seed set and the paragraphs, who take the adjective as the researched object, constructs a seed set of the positive and negative emotion words. Strip verb C and the seamed part of the speech, such as noun, verb, and the adjective on the base of the who, and the prose of the comprehension emotion categories based on word net and in the inflection multi-part of the speech. Chong proposed a substantive mid-word stagnation, automatic based on the preparation layer of the frame net. Giles used the Russell's model to capture the emotion vocabulary of the online social media by deleting the low frequency and non-emotion words, and returns a repeat of the words. The special idea as follows. The emergence of the inflection words are usually repeated and the challenge of the emotion plurality, which will produce the different emotion words, where the juries on journey repeat to the progress the connection of the emotion and usually produce the words with the same or similar emotions. However, in the field of the discovery such as the prose, the use of the words is flexible, and it's not enough to judge the emotional property of the words only by conjectures. The combination of the compass and semantic knowledge can improve the achievement of the emotion targets. BiLSTM proposed an unsupervised emotion classification method based on the multi-level further classification and multi-criteria fusion. This part, I will introduce the method design. This paper proposed an unsupervised construction method on the poem emotion lecture based on multidimensional fusion. Through the data collected of the Prose website, the best corpus is collected. The emotion lecture of the Dalian University of Technology is set of the basic emotion lecture. After the diagnosis and the processing of the compass, multi-sectory are the integral two forms of C-set. By construction point, multi-information PMI, word construction of the word vector, and the joint semantic vector of the semantic information of the prose text. A comprehension vector space based on the prose compass is formed. Finally, the random word space structure is used to obtain the candidate semantic word set which is similar or similar to the C-set. And the semantic lecture in Prose field is complexed by using the classification authorities. According to the implementation method of this paper, the main construction progress is as follows, shown in the figure. The construction progress is as follows. First, data progressing. Second, word vector construction. 3. Synthetic vector space classifier design. 4. The construction of the emotion lecturings is commonly used in prose. The emotion detector in the field of the poem is mainly composed of two parts: fusion emotion lexicon and candidate emotion lexicon. The classifier model is used to classify and judge its emotion property. And finally, the common emotion lecture in the field is prose is obtained. This study focused on the prose and needs a large number of the prose corpus. This paper designed to use the network collection tools to obtain a network common prose corpus as the candidate corpus. The special design and collecting of the prose corpus are shown in the table 1. It can be removed, duplicate date, and filter candidate plot. Finally, the collected results are merged into the semi-structured XML document of the prose text and corpus. The structure of the contents, topics, authorities, and text. The database collected the masterpieces. Then, the experiment used the patient's beautiful soup laboratory and collected the analyses. Then got the Prose compass. A total of more than 7,000 affected words were selected from the intersection of the and the Chinese emotion vocabulary database. After classifying the emotion lecture into the 7 categories: sadness, even, good, surprise, fear, anger, and happiness. By analyzing the content of the proposed compass, it's easy to get the word in the prose and the more implicit and profound in expression emotions. PMI is a special case of the NMI, and NMI is the content divided into the information series. Now, we defined these three methods. First, define 1, and define 2, and 3. Briefly speaking, the connection property between the point is used to measure by the random work characteristic between words, which is a subset for the global excited meaning and the opposite of the graded delicate. Then the vector is a similar properly distributed from the word to the seed set. This part, we show the experiment result and analysis. In the table 1, collecting the linked organization, and in this table, the candidate word sequence is obtained by taking an intersection with the Chinese emotion vocabulary database. Then we find, according to the analysis of the above result, the good and even are the theme in the prompted compass, and there are few articles above the anger. According to the experiment result of the one and the others on low frequent words, we combine the experiment result in table 3. Therefore, other mapping of the information lecture into the 7 categories, 10 emotion words, and random select as a seed set. Table 4, seed set of each emotion label in the random walk model. In this part, we can see the classification. A copy of the emotion word in this paper has been significantly improved the 7 decades. And the second is the word-to-vector method. PMI method is the word with words. And from the result of the table of current emotion words, we can see that the highest number of the emotion word identified by the adigraphs, and PMI is better than the word-to-vector in emotion word recognition, but is not as accurate as word-to-vector in the classification. Now, summary. In this paper, a domain compares the words construction by the progress. First, the conjunction between the words is fully considered. Second, the seed set is selected random by analyzed by the category. Third, the cooperation degree is constructed by PMI and virtual vector. Then the synthetic vector space E is constructed. After data, the method has good effect. Due to the difference in the personal life in experience and life in attitude, the emotion type and the expression way of writers often have their own characteristics. Therefore, it puts forward better requirement for the fine classification of the emotion lexicon. In this paper, with the help of the data collection tools with more than 2,000 pieces of the model famous plus the database are concreted after purpose of the database, denoting, delecting, and select from the complete of the domain of the word set. Compared with the PMI and word vector, the method is improved of the 13% and 14.8%, which proves that the comprehension vector space can effectively improve the emotion vocabulary and recognition of the pose. This study is supported by the following 3 projects. Thank you very much.
algorithm based on LLCBF for large flows identification. The paper consists of the following parts: introduction, classical list recent use algorithm, strategy used in our algorithm, identifying large flows by LLCBF algorithm, performance and experimental analysis. Part 1. Introduction. Accurately measuring and monitoring network traffic is the basis for managing large-scale networks. However, along with the rapid expansion of the Internet and the continual emergence of new applications, network traffic presents the characteristics of high speed, large scale, and complexity. And the obvious feature is that the large amount of data generated and the high frequency of data packet arrival. This requires shorter data processing time than before, which brings great challenge to the storage capacity, processing capacity, and the transmission capacity of the network measurement system. Fortunately, the flow-based measurement method opens up a new way for flow monitoring. By merging packets into the flow, the data volume is greatly compressed, making the storage, processing, and transmission of network data easier. Some attributes of the packets are mapped into the flow to represent a unique identifier for the flow ID. The most common used flow specification is the file tuple of the packet header, which is source or destination IP address, source or destination port numbers, and transport protocol. Many studies show that the statistics of network flow present a strong heavy-tail distribution. Heavy-tail distribution is a probability distribution model, which means that in the statistical set, a small part of the elements have a very high frequency of appearance, occupying the vast majority of the set, and most of the elements appear at a very slow frequency. This characteristic is called the elephant and mice phenomenon, which means that the most flows only have a small number of packets, while a small number of flows have a large number of packets. A notable feature of large flows is that they only account for a small part of the total traffic, but generate the vast majority of the total traffic. So, in practical applications, in most cases, we only need to master large flow information to have an overall understanding of all network flows. Traditional methods to achieve large flow identification is to collect all the packets in the network, and then extract their flow statistics, just as many previous studies have indicated. However, for the reason of the system hardware, computing speed and the storage capacity is limited, and the network traffic data scale is huge, and the message arrival speed is extremely high. For example, on the OC 768 backbone link, the average packet processing time is 8 nanoseconds. We propose and implement a new method called LLCBF algorithm, which use list, LLU, and CBF algorithm to realize large flow identification. Part 2. Classical list recent use algorithm. List recent used LLU algorithm has a wide application in the computer field, such as database cache management, page management, disk cache management, and so on. The fundamental of LLU is that always keep the new element in the top of the cache, and keep the least recent used element in the bottom. In an LLU cache, every new entry is placed at the topmost position in the cache. Small flows are likely to be replaced by other flows. Large flows are expected to retain their entry in the LLU cache for long periods of the time. However, when there are too many small flows or short-lived flows arrived at the cache suddenly, the large flows will be replaced by the small flows. This will decrease the accuracy of the measurement. To solve this problem, we propose a new method. Part 3. Strategies used in our algorithm. In order to solve the shortcoming of LLU algorithm, that the small flows will replace large flows frequently, we improve the LLU algorithm from 4 aspects to improve the measurement accuracy. First, large flows handled first. Second, using counting bloom filter to filter most small flow packets. Third, using the LLU mechanism to filter small and medium flows and protect large flows. 4. Using list elimination mechanism to identify large flows. Large flows handled firstly. In order to identify large flows at the router, LLU algorithm must employ a cache which is a fixed predetermined size. For the reason of the number of memory we can afford is significantly smaller than the number of flows. When many small flows arrive at the cache suddenly, the large flows, including the large flows that already identified, will be replaced by the small flow. To avoid this situation, we proposed large flow handled firstly, which means that when a packet arrives, algorithm will validate whether this packet is belong to a large flow which has been identified. If it is, then update the flow information. If it is not, then packet will be handled later by other module. By this way, large flows which identified before will not be replaced by small one. Using counting bloom filter to filter most small flow packets. Now that flow statistics have a characteristics which most small flows have a small number of packets, while a very few flows have a large number of packets. If we can filter out the packets of small flows before they enter LLU cache, this will reduce the number of flows which LLU algorithm handled, depress the probability of large flows replaced, and then will improve the accuracy of LLU algorithm. Counting bloom filter is a set S of n elements, which is described by an array of m base. initially all set to 0. It uses k independently hash functions which range 1 to n. When adding an element, CBF uses k hash function to map into the corresponding storage space and add1 to the value of its mapped position. When deleting the element, the values of the corresponding k position are reduced by 1. We use the characteristics of CBF to filter most small flows. When a packet arrives, k hash functions are used to hash the flow ID of the packet, which will be mapped into different positions of the CBF. Since all the packets belong to the same flow will be mapped into the same location, the value of the large flow mapping location will be larger. For most small stream packets, the value stored in the mapped location is relatively small because of the different spatial location of the mapping. By this way, most small flows can be filtered through the present preset threshold N1, that is, when the value of the mapping position of the message is larger than or equal to N1, the message will be processed by the subsequent module. Most of the small flows are filtered out by CBF because they contain less packets and the value of mapping position is small. Using the LRU mechanism to filter small and medium flows and protect large flows. The LRU module is used to filter the middle and small flows passing through the CBF module, reducing the number of flows entering the list module, thereby achieving pre-protected for large flows. The LRU maintains a cache and always keeps the flow which records of the latest arrived packets at the top of the LRU cache. When a new flow reaches the LRU module through the CBF module, the LRU module will create a new flow record and place it at the top of the cache. If the cache is full, the bottom flow will be replaced. Due to the short duration and the low arrival rate of the small flows, they are always possible to be replaced, while large flows tend to be stored at the top of the LRU cache because of their long duration and the frequent access to the cache. However, due to the small storage space of the LRU, when a large number of burst flows arrive or no new packets arrive in a short period of time, large flow objects may be eliminated by the medium and the small flows. Therefore, it is necessary to further use list module to identify large stream objects. Using list elimination mechanism to identify large flows, the list module always eliminates the smallest flow and realizes long flow identification. If the flow object passing the throw set by CBF and the LRU, a new entry will be added to the list table to record the information of the flow. When the length of the list table reaches the maximum, the smallest flow in the list table will be eliminated in order to free up storage space for the newly arrived flow. Part 4. Identifying large flows by LRCBF algorithm. The structure of LLCBF algorithm is shown as follows. The large flow identification algorithm based on LLCBF is composed of flow filtering function and flow identification function. The procedure for identifying large flows by LLCBF algorithm. First, when a packet arrives, k independent hash functions will be compute k keys according to the file tuple identity. Secondly, validate whether this packet is belong to a large flow. If it is, then the counter of large flow is 1. If it is not, then packet will be handled by CBF. CBF validate whether the key position of the CBF are all less than n1. If any of position is less than n1, the counter of each position plus 1. Otherwise, the packet will be handled by RRU algorithm. RRU algorithm will search the cache to check if that flow's entry exists in the cache. On miss, the flow is added to the cache if there is space in the cache. If there is no space in the cache, it replaces the least recently used entry. It is entry in the topmost position in the cache. On a hit, update the entry in the cache. When the count of this flow exceeds the threshold n2, this flow will be submitted to the list module. In list module, this algorithm will search the cache to check if that flow's entry exists in the cache. If found, then the size of the packet is added to this record. If not, it will determine whether the lib cache is full. If reached the maximum size, the smallest flow in the list will be eliminated. If not, then a new entry will be added to the list table to record the information of the flow. At last, output the flows which length is greater than the specified threshold th, which we record in the list, and those flows are large flows. Part 5. Performance and experimental evolution. Performance evolution. The algorithm may have false positive during the large flow recognition process. False positive residue is the probability of identifying non-large flows as large flow. False positive residue is shown as follows. Experimental analysis. We use the trace collected from CIDE for simulation experiments. There are about 6 million packets and 68,000 flows in the total. CBF use k equal 6 hash functions, and its hash space is 0 to 65535. The original distribution of network traffic is shown as follows. Comparison of large flow pre-processing and post-processing is shown as follows. The measurement accuracy of large flow handled first is much higher than that of post-handled. This is because of the post-processing method will cause the large flows to be eliminated by the small flows. Thus, the measurement accuracy is reduced. the proportion of the number of filter flows when the CBF counter changes. The greater the value of the counter, the more flow are filtered. As the counter flow increases, most of the small flow are discussed because of the value of mapping position is smaller than the counter. Measurement error when LRU cache space changes is shown as follows. The larger the cache space, the smaller the probability of the large flow being replaced and the higher the accuracy. Comparison of the accuracy of 3 algorithms for measuring large flows. Experimental results show that, compared with the standard LRU algorithm and LRU-BF algorithm, the LL-CBF algorithm proposed in the paper has higher measurement accuracy, especially when the cache space is relatively small. The advantage of the LL-CBF algorithm is more obvious. Part 6. Conclusion. In this paper, we propose a large flow detection algorithm based on LL-CBF, which will filter out most of the small flow through filtering mechanism and reduce the probability of small flow entering the cache space. Realize the strategy of grasp the big and let go of the small. The complexity of error rate of the algorithm are analyzed, and the effectiveness of the algorithm is verified by experimental data. The results show that, compared with the standard algorithm and the LRU-BF algorithm, the new algorithm can identify the large flow in the network timely and accurately, under the condition of using less storage space, and meet the actual measurement needs. Thanks.